SAS Basics Programming Lesson 1. Introduction. Here's an outline for a 10-lesson module on how to learn SAS Basics Programming. Each lesson builds on the previous one, focusing on essential concepts for beginners. Lesson 1. Number 1. Introduction to SAS and the Programming Environment. 1.1. Overview of SAS and its applications. 1.2. Understanding the SAS interface, SAS Studio, SAS EG Guide. 1.3. How to write, run and debug a basic SAS program. 1.4. Structure of a SAS program, data and proc steps. What is SAS? SAS is a software suite for data management, advanced analytics, predictive analytics, and business intelligence. Uses of SAS in various industries such as pharma, banking, government, and CROs. Different SAS interfaces. SAS Studio. SAS Studio is a web-based interface for writing and executing SAS programs. It features such as code editor, libraries pane, and results viewer. So this studio, it will help you write your executing your programs. It will also show all the libraries that are existing, and it will also show you the results viewer. Whatever you are writing the codes, you will run those codes and you will also see the results. Next is SAS EG, which is SAS Enterprise Guide, a GUI-based interface that helps users without programming knowledge run tasks and generate code. So say for example, you can say it's an automatic kind of a SAS code it will generate. Just if you click on the prog means or how to generate means or how to calculate the counts and percentages. So it will show you some menu options. So you just have to click on that. That's why it's a GUI interface where it helps the users to just click the specific procedure and the option or a specific analysis. So it will run the task and it will generate the SAS code automatically, and also it will generate the log and it will give you the results as well. So it will also create a specific code that has been used to generate the results. So you can see that in the back end. SAS WE, traditional desktop environment for running SAS programs locally. Explain when and why each interface is used. Focus mainly on SAS Studio for the course. So generally we use SAS Studio as main course in most of the SAS version softwares that are available. Understanding the structure of a SAS program. Now the first is the data and proc steps. Now there are two kind of steps which are available in the specific SAS program script, right? So first is my data step and second is the proc step. So let's understand what is the difference between these two steps. Now the basic building blocks of any SAS program are the data step, which is used for data manipulation, like say creating variables or assigning any variable attributes. Now attributes is nothing but you will be assigning your length, then format, in format, then you would like to specify whether it's a character variable or it's a numeric variable. So all those kind of data manipulation, like say for example you are doing the filtering, you are using the where clause, you are using the if and then clause, you are using arrays, or you're doing any some manipulation if and then clause that you're using. So those are all manipulations that you do, or you're doing some changes in that specific program so that your data set, it looks in a specific way, the way you want, right? So that thing happens in the data step. Now, and the another thing is a proc step. Now proc step is the procedure step where it uses a specific inbuilt process of like generating the analysis, like say for example prog means, proc frec, which gives you counts and percentages. So these are the inbuilt procedures which are written in the SAS software. So once you use that specific program, it will generate the summary statistics for that specific variable. So say for example I have a age, so that age, the prog means it will generate the age, like say summary n, mean, standard deviation, then min, max, and the range. So whatever the quartiles, deciles and percentiles, whatever that you would like to use. So these procedures are also used for sorting. So say I have a prog sort, then prog reporting is you will use prog report. So there are various procedures that are available in the inbuilt SAS software that you have to write a specific script in the SAS software. Now once you understand that specific script, and once you enter the exact way, the way the software understands, you will get the correct results. Now if you do not understand the SAS procedures better, and if you somehow if you just write whatever you feel like, so it's not going to give you the correct analysis. So it's very essential that whenever you use any procedures for doing any kind of analysis, first you need to understand the syntax of that procedure. It could be prog report, prog sort, prog means, or prog frec. So once you have understood the syntax properly, only then you will be able to write the script or the SAS program properly in the SAS code editor, and then only you will get the accurate and the correct results. Otherwise everything will fail. Now the SAS program flow. SAS processes code sequentially, executing one step at a time. So what happens is, like say for example, I have a code editor. Now what is an editor? Say for example, in a very simple language I would like to explain is, you see the notepad. The way you see a notepad, in notepad you write a specific sentence, or you write a specific paragraph, right? In the similar way, in this specific SAS software, you will have a code editor. Now that editor, inside only that you have to write the SAS programs. Now once you have written those SAS programs, what happens is, the SAS software, it processes the code sequentially. So whatever the data step you have written first, so it will execute the data step first. And if you have written the proc step or the procedure analysis second, then it will process the procedural analysis. Now say for example you have written the proc step before, and then you have written the data step, like say managing or organizing or arranging the data. Now in a very simple layman's language, I would like to explain here is, data step is nothing but you are using this particular step in order to have your data set in that specific way you want, so that you can perform the analysis and you can get the exact results the way you want. So say for example I want the age in specific numeric decimals or something like that. So all those decimal manipulation you will do in the data set. So say for example I have written the proc step before, and then I am doing the data step and manipulation. The SAS software will not recognize the data set that you have entered in proc step. Why? Because you are first conducting the analysis, or you are doing the procedural step that you are using. That means you are doing any process, or you are processing any statistical analysis, right? So if you're doing that before creating the data step, it's quite logical reason that it will throw you an error, and the SAS will not understand what is it that you're doing. So the first step is to organize and to manage and to build the data set in such a way so that it becomes very easy for the proc step to do the analysis, and it will give you the required results. I hope I'm clear on this. So the SAS processes code sequentially, executing one step at a time. Now each statement ends with a semicolon. Every step ends with a run statement or quit statement in some procedures. Now it's a very basic thumb rule of SAS software that every statement, whatever you write, it should end with a semicolon. It's a very important kind of quotation, right? If you don't use this quotation, like say semicolon, your program will fail. It will not execute. Either it will go in loop or it will throw you some error in the log, right? And every step, whatever you're using, like say for example, I'm using a data step or I'm using a proc step. So I have to end this specific step with a run statement. So I will run and then I will use the semicolon. So say for example, I completed writing the proc step and you don't, specify the run statement, then also it will go under the loop and it will not execute properly. So if you write a run statement but you have not mentioned the semicolon, then also it will not execute properly. You can try this in any software. It will throw you some of the other error or it will go under the hanging mode, right? And it's very essential that every step, either data step or proc step, it should end with a run statement followed by a semicolon, or it should end with a quit statement. Now quit statement, why it should be used? Because like say for example, you have large amount of data. Say you have around thousands or 2000 records, or more than 10,000 or 20,000 records, right? So in those scenarios, whenever we use any prog SQL, so prog SQL is a particular process that it uses, takes very less time, and you want to come out of that particular step much faster. So in that particular process, whenever you have any large data set, or whenever you want to come out faster and you want to finish the procedural step or the proc step, much faster, you can use the quit statement, so that it does not go under the hanging or it does not take the much waiting time, right? So the basic thumb rule in SAS software is there are two steps. One is data step and the another is proc step. And the second thing is SAS processes code sequentially. So whichever the code you have written first, it will execute that, and next whatever the code you have written, only then the code will execute. The third thumb rule is every statement should end with a semicolon, and the fourth thumb rule is every statement, whatever you are writing, step, data step or a proc step, that has to end with a run statement followed by the semicolon. Now these are the basic thumb rules that you should understand the structure of the SAS program. Now say for example, it's a very basic concept, like you are trying to understand the script. Say for example, I do not know English. So for understanding English, I will learn A, B, C, D, right? So once I learn A, B, C, D, then I will try to form a sentence. Then I will try to form a paragraph. Then I will try to form a specific essay or a letter. So in a similar way, so these are the basic thumb rules of SAS software that you should know. Once you have understood this and once you have followed this, it will be very easy for you to understand and implement the SAS program in your whichever workflow or whichever in a personal or a professional life. Writing and running SAS program. Now say for example, this is a specific data step. Now as you see in the screen, in the slide, there are two steps. First is my data step and this is my proc step. So say for example, this piece of code, whatever is written, this is my data step. Okay, this is my data step, and whatever this is my proc step, right? So the first step is my data step. So this is my data set name, which is example, right? And I'm ending this sentence with a semicolon. Input is nothing but I'm trying to inform, or I'm trying to generate those variables, like I'm inputting these variables in this specific data set. Which data set? Example, right? So I'm inputting name with a dollar sign. Now this dollar sign is very important. The dollar sign indicates that this specific variable name is nothing but a character. Now age, height and weight. So in this input statement, I have four variables, which is name, which is character, hence I'll put $sign in front of that variable. If it's a numeric variable, I need not put a $sign, right? So you can just skip that character. So this is age, height and weight. Again, see, if you I'm closing this statement with a semicolon. Now data lines is that specific statement where you inform the SAS software that after this data lines and semicolon, okay, I am going to enter all this data. Now all this data which I am entering, and these are my data lines, that will be reflected in the data set, which is my example, right? So the first row, it will read as John, then 25 is the age, 175 is the height and 70 is the weight. Similarly, Alice is the name, 30 is my age, 160 is the height and weight is nothing but 55. Again, when I read through the third row or the third record, the Tom is the name, which is character, 22 is the age, height is 180 and weight is 75. Now once I've completed writing this very simple basic data lines, or like, informing the SAS software that after the data line statement, whatever records or whatever the lines that you see, those are all my data that needs to be feeded or that needs to be added in what data set? In example data set. In what structure? In name, age, height and weight variables. I hope this is clear up till now. Now once I'm done this, you see I have to close this with semicolon. If you don't put this semicolon, it will not understand that the data lines or the entry of the records in this specific data has been stopped. So you have to inform the SAS software that this semicolon is nothing but it informs that these are the only three piece of code that needs to go into the data set, right? And then every data step needs to be end with the run statement followed by the semicolon. So that is the thumb rule. So again, if you see, this is my run statement, right? Is it clear? So it's a very simple data step here which I am explaining here. Now next is the proc print. Now this proc print, what it will do, in a very common layman's language, print is nothing but it will print. What it will print? It will print the data. What data it will print? It will print the example data set. Now whatever name that you give after the data, right, that is nothing but the name of your data set. If you're not entering any libraries, it will go by default in the work library. That I will explain in the next slide, what is permanent and what is the work library. So right now you need to understand that this dataset example that is created, it will go into the work library. So this specific procedure, right, the proc print procedure is nothing but it is informing the SAS software to print the data set example the way it has been entered in the data step by the data step procedure. So once you write this proc print data, it will equal to example and then close with the run statement and followed by the semicolon, it will show you the print of the data set, like what the contents of the data set, like say for example how many rows are there or how many columns are there. So from this you can understand that there are 3 rows, right, and there are 4 columns. One is name, age, height and weight. So that you will see in the results viewer of the SAS software. So you can write this piece of SAS program if you are a beginner or if you are a newcomer, and if you don't understand, you can understand this better. You write this piece of code in the SAS code editor. You check the log, which is a SAS log, which again a txt file, and then you can check the results viewer, which you will see in the viewer kind of tab. There you will see whether it's in PDF, RTF, or whether you have selected HTML format. So those results you will see in the results viewer tab. So this is the very simple basic program that I have explained. 2 steps, data step and proc step. SAS log output and results window. Now SAS log, it tracks the execution of the programs, displays errors, warnings and notes. It is important to check the log to identify syntax errors or logical mistakes. So it's very essential that whenever you write any SAS code, make it a natural habit to check the log before you check the results. Results can be checked later. Once you see that there are no errors, warnings and notes in this SAS log, then you can proceed with the results window. The SAS output is nothing but where results like procedures, tables or summaries that they appear. And results is nothing but in the case of procedures that generate more visual outputs, graphs or advanced reports, these appear in the results viewer. So you can see the SAS log, output and results viewer. Now these are the three windows that you will actually see in the SAS software. Once you have got access to that particular software, you will see these windows. So you need to understand, one is the code editor. SAS log is where you can check the log, the audit trail of SAS programs, you can say in that way. Output is nothing but it will show you the results, and the SAS results is nothing but if you want to see the HTML, PDF or RTF, so you can see in that, like say for example I have a graphs or advanced reports, so that you can see in the results viewer. Assigning a library in SAS. Now SAS libraries are used to store and organize data sets. There are two types of library, work and permanent. Now work is a temporary one and permanent is nothing but the saved, which is like say for example is a physical path where you have assigned to your location, to your C drive or a D drive. So that is the permanent. So that permanent library name you have given to that specific path where you will be saving your data sets in the physical drive, which is C drive, D drive or whatever is your save. So those are my saved libraries. Work is the kind of a library where it's a temporary one. The moment you open the SAS, whatever work that you do, everything will get saved temporary in work library, unless and until you give a name to that specific library, or unless and until you assign a permanent library, right? So once you close the SAS software, whatever that data sets that you have generated, everything has gone. So you have to close it, and once you reopen it, you will not get all those data sets back. So if you want to get all those data sets back, you need to ensure that you give a physical path to that specific library name, and you give that specific path to that library name, and then you can save it. So that is nothing but the permanent library path where you have saved all your data sets. Now this is a specific code that libname is nothing but the syntax that you inform to the SAS software that this is a syntax I'm using, that means assigning a library name. So my lib is nothing but the library name, and C colon whatever is the path, let's say for example my path. So say my path is a folder and C colon is your drive. So this specific path is the library name reference that I'm giving as my lib, and whatever data sets that I'm generating, and if I use this reference like my lib in that specific data sets, all those data sets will get physically stored where in this specific path. Now the SAS code explanation. So this is a lib name statement, library name and the physical path of library to store data sets, which I just explained a few seconds before. Best practices for writing SAS code. Number 1, use proper indentation wherever applicable. Now indentation is nothing but you see data step, right? So this is the data step. You are giving the data set name, which is ABC. Now your setting means you are using some other data set as a reference and you are creating new data set as ABC. and you're using the old data sets which is XYZ as a reference or as a copy, right? And whatever variables and the records which are there in XYZ, you are creating a copy of that in ABC, and whatever manipulations or changes that you do, it will reflect in ABC but not in XYZ. So XYZ is nothing but the reference data set that you are using for making any changes in the new data set which is ABC. Now here I am talking about the proper indentation. Indentation is nothing but, you see here I am given this specific 2 or 5 spaces. So you have to use proper indentation so that your SAS code looks neat, clean. It should not look like, jumbled or messy or like, fumble up kind of programs. Every time you ensure that your SAS code should look neat, clean, readable, and it should be properly formatted and properly indented. Number 2 is emphasizing writing clean and well organized data, which I just said earlier. So here is the proc sort data equal to ABC. Now here if you see, I am using after data I am using a space and I am using equal to sign, and after this equal to sign I am again using space, I am using ABC. Now after ABC I am again using a space and I am using a semicolon. So this is kind of a format which is organized, readable, and like you can see neat and clean that okay, this is the data set name ABC, and I'm using this running this statement, closing it, and this is the proc sort whatever. So it becomes very easy to understand, and it becomes very appealing to read, so that it much becomes faster to grasp the code for any newcomer. So third is use comments for documentation purpose. Now, whenever you write any comment in a specific SAS code editor, you write this backslash and the star, and then you write whatever statement that you want to write, and then you can close this star and you can close this slash. So this is the general thumb rule, the way you write the comments in the SAS code editor. Number 4 is use clear descriptive names for data sets and variables. Now, remember one thing, whenever you are giving any names to any data sets or variables, ensure that as far as possible you follow the CDIC standards. The reason why I'm telling you is, once you keep a habit of giving the names to data sets and variables as per the CDISC standards, no matter even if the project is not of CDISC standard, or it's not for the CDISC submission, but if you follow this best practices, believe me, it will become very easy, and it will become a habitual kind of scenario where it will become very easy to remember the CDISC names, terminologies that are used for the data sets and variables, what are the rules and what are the regulations that you follow the CDISC standards. So always use clear and descriptive. Do not give any vague kind of names, so that nobody will understand. So it should be very appealing and relatable kind of data sets and variable. So my preference would be and my suggestion would be, like, even if it's a non CDISC project, always ensure to follow the CDISC names for data sets and variables, so you will always be at a plus point or at a positive point, so that you don't need to make extra effort in learning the CDISC name and standards, right? So it will become very easy for you to implement the names, data sets, variables for writing, remembering, and following up, reading. Some other person has written a specific code, so for that to also understand, it will also become very easy for everyone, not for you, it will become easy for everyone if everybody follows good practices, best practices, and neat and clean writing. So everybody will feel comfortable in reading and understanding if it is well organized. If it's a haphazardly organized, it will not be very fruitful. So try this, it will work in every situation. Anything that you do in your life, it should be well organized, neat, clean, and properly used, with a meaningful situations for giving the names, so that everything falls in the better place and you finish your work in time and with a quality kind of a work that you deliver. So that's the only agenda, or that's the only thumb rule as to why you should follow the CDISC naming conventions, even though if it's a non-CDISC, right? So it will become a habit, and once it becomes a habit, it becomes very easy for, like, to get adapted to any situations that you go in any organizations. Summary: SAS is a powerful tool for data analysis, and mastering its environment is key to learning the language. A basic SAS program is divided into data steps and proc steps. The SAS log is crucial for debugging and ensuring your program runs smoothly. Hands-on exercises. Exercise 1. Write a simple data step to create a data set of your choice, for example, a list of students with age and grades. Exercise 2. Use proc print to display the data set in the output window. Please like, share and subscribe. Leave a feedback comment mentioning any topic that you want me to make a video. Looking forward for a positive response. Thanks for watching. Please like, share and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.